promised, I'll be introducing the webinar and covering a few housekeeping items. First, all attendees are muted, but this doesn't mean that you can't ask questions. Feel free to submit them throughout the webinar. To do so, use the GoToWebinar control panel, open up the question tab, and type in your question. We'll do our best to answer questions posed during the Q&A session at the end of the webinar. 1 or 2 days after the webinar, we'll be posting a video recording of the presentation along with the presentation slides. We'll send out an email with links to all the materials. After the webinar, feel free to contact the presenters directly using the information that is on their slides. We'll also send this out via email. And finally, if you'd like to tweet about the webinar, we'll have a couple of hashtags up on the screen in just a moment. The webinar should last about 60 minutes, and hopefully I think it'll be fun and interesting for everyone. So let's start with introducing our speakers. So our primary speaker today is Shekhar Gulati. He's a Red Hat employee, and he's OpenShift's developer evangelist. His background is in Java and JavaScript, various other languages, as well as a strong base, as you might guess, in the cloud. Our Magnolia expert on hand today is Daniel Lipp. Daniel is one of our senior software developers. His slide should come up any moment now. Daniel has an interest in Java, of course. He's got a strong background in Smalltalk, and once in a while he likes to do odd things like run on Basel's city streets with many other people. So the agenda that we'll cover today, also one moment, there's a little lag in the slides showing up. So first we'll give a brief introduction. Most importantly, what we'll cover are the benefits of deploying Magnolia CMS on OpenShift, some of the use cases you might want to cover, some of the deployment scenarios for Magnolia, and a bit of background to help the demo, which comes next, make more sense. With the demo, we'll cover a basic deployment scenario for Magnolia, going from registering an OpenShift account all the way to pushing code live and getting instances up and running. After that, Shekhar will give you an overview of how OpenShift works so you can better understand how to use the tool with other projects. Then we'll have a Q&A session where you can ask more advanced questions about topics such as different deployment scenarios, dealing with upgrades, and so on. And with that, I'll happily hand over to Shekhar.
Yeah, so these are a couple of hashtags that you can use in this webinar, so OpenShift and Magnolia CMS. So now let's start with what OpenShift is so that we get a better understanding of the platform. So we will start with a brief introduction about that, how we can help you deploy Magnolia CMS in the cloud. So when we talk about OpenShift, we are talking about a platform as a service. So by platform as a service is one way to deliver cloud computing. So when we are talking about cloud computing, we are talking about compute resources available over the network. It can be delivered using multiple ways. So one of them is IaaS, or infrastructure as a service, where you talk about only compute resources available over the network. Then you have to install everything that you require to build an application. So if you are trying to build a Magnolia CMS application on IaaS, so you have to have a Tomcat or any other container. Then you need to install Java, you need to install database, and then you work with your application. The other extreme of delivery model of cloud computing is software service, where you have your end application, which you can't customize a lot, but it's an end product that end users can use. When we talk about platform as a service, we are talking about something in between, where you have all that is required to build an application. So OpenShift falls under that category. It's a platform as a service, which means that we are providing you an application stack that you can use to build applications. By application stack, we are trying to say that we are providing a managed stack. Like if you need a Tomcat container, you need a database like MySQL or PostgreSQL, we provide that for you. We manage that for you. We provide the security patches and everything that is required to make sure that your environment is up and running. So platform as a service provide all the things required by developers. So it is a very developer-centric way to consume cloud computing, whereas IaaS is very ops-centric or operation-centric way to consume cloud computing. OpenShift is a platform by Red Hat, so it's a Red Hat product. It is based on Red Hat Enterprise Linux, the Red Hat product. It is a multi-language platform as a service. So these days, people are trying to move towards using multiple programming languages in a project to solve different use cases. So you can use Python for some, Scala for some, Java for some use case. So you have to have a platform which supports multiple programming languages, which is called polyglot programming, that you should use multiple programming language, and depending upon your use case, you should choose the best language. So we support different languages that you can use to build your application, Java being one of the primary language that we support. Apart from the language support that we have, we also support different databases. So we have support for MySQL, PostgreSQL, MongoDB, different databases that we support. One of the key points with the platform as a service is that it has to be auto-scalable. By auto-scalable, it means that it has to support horizontal scalability of your application. You can't just rely on a single virtual machine, single server to handle your application. You have to horizontally scale that out. So with OpenShift platform as a service, you can at the application creation time, you can specify that my application should be scalable, and we will manage a cluster of Tomcat or JBoss containers for you, and you don't have to worry about horizontal scalability and clustering of those containers. Another important point about platform as a service is that it is a self-service delivery model, which means that you don't have to go to an IT person to say that I need a machine which should have, I need an instance which should have Tomcat and MySQL in it. You just type a command and platform will automate that for you. It will give you an environment that you can use to build application. So it is very productive. It is an environment which drives business agility, and it provides you rapid development for your applications. The last point that is the key is that it's a cloud application platform, which means that we are not just a public platform, we can also be a private platform. So we can run on anywhere where Red Hat Enterprise Linux can run. So it can be a private IaaS like OpenStack, or it can be a public IaaS like Amazon EC2 or Rackspace or Google Compute Engine. So we can run on any cloud platform, be it private or be it public. So the core essence is you write your application using the IDE or a text editor that you like. You write it, you commit it into a repository, and you push it. Once you push it, the platform will take care of building your archive or your WAR file or your ER file and deploy that to the managed infrastructure that platform as a service supports. So as a developer or as an organization, you are free from that. And that's how you get a better time to market, or you can deliver your software faster. Now, every platform as a service has to support an application stack. And by application stack, we are talking about what are the different languages that we support, what are the different application servers that we support, what are the different databases that we support. With OpenShift, we support everything that is standard, which means that we support standard MySQL, standard MongoDB, standard PostgreSQL. So you are sure that your application behaves the same if you try to move away from OpenShift. So today you are using OpenShift, but you want to move away from OpenShift and want to host yourself. Because you're using standard tools, you don't have to worry about that. On Java side, we support Tomcat container and JBoss container. All of these functionalities are called cartridges. Cartridges are what drives the functionality. So cartridge could be a language runtime, it could be an application server, it could be a database. Fine. So when you create an application, you specify which all cartridges I want to have in my application. So you can say that I want to have a Tomcat cartridge and a MySQL cartridge, and we will install everything for you. OpenShift is an open source platform, and it is extensible by nature. So right now we support Tomcat and JBoss as our two containers. But let's suppose you want to use Jetty, which is another web server, to host your Magnolia application. So what you can do is that you can write a cartridge for OpenShift, which will install and manage Jetty for you, and you can use in a standard way. Another key point that OpenShift tries to focus is that we are trying to use the standard tools that are in industry. So for example, in Java, we use Maven. So Maven is our dependency management tool for Java. We have tight integration with Eclipse. So we are trying to use what people use and normally developers use. We are not trying to come up with new ways that people should use. Similar is the case with Node. We use npm for dependency management. Similar with Python, we use requirement.txt and pip for all managing the dependencies. If you support continuous integration, if you in your organization you use continuous integration, then we have support for Jenkins. Again, Jenkins is the de facto for continuous integration. So while creating your application, you can also specify that I want my application to be built by Jenkins. So we can configure that for you. So the point is, we are trying to support the standard stacks that is required to build your application faster. And you can extend it at any point of time. You can write your own cartridges. So we support Python, Java, Node, Ruby, and Perl as our language stack. And you can run any framework that you want to on those stacks. OpenShift in itself is 3 projects actually. So OpenShift is an open source project. So OpenShift Origin is the open source project. So anybody can go to github.com/OpenShift and find the OpenShift source code there. So all the development of OpenShift happens on OpenShift Origin project. Anybody can take the bit and create their own platform as a service they want to. It will not be supported by Red Hat, but it's an open source project, so anybody can do it themselves. There are 2 downstream projects of OpenShift, which we can say there are 2 paid offerings of OpenShift in terms of OpenShift Online, which is a public platform as a service. The second is OpenShift Enterprise, which is an enterprise platform as a private platform as a service solution. With OpenShift Online, you don't have to manage platform as a service yourself. It is the responsibility of the provider, that is Red Hat, will do that. So you just go to openshift.com, sign up for an account, verify your email, and you can get started with application development. You don't have to manage the platform yourself. This is very good for developers, very good for startups, but for big organizations like Cisco, Accenture, who use OpenShift, they go with OpenShift Enterprise, where they have their own data centers and they want to install OpenShift on top of that. So OpenShift is packaged as a private platform as a service there, and people can use OpenShift Enterprise for that, and Red Hat will support that. So in this demonstration, what we will talk about, we will mainly cover OpenShift Online because that does not require any installation, and you at your home or at your office can just try it today itself. So let's look at what are the benefits and use cases of using OpenShift. So when you talk about platform as a service is just not a production deployment environment. Platform as a service is from development to production. So platform as a service provides you a way, like OpenShift provides you a way to create a standardized development environment, which means that you will get a standard Magnolia stack, which includes Red Hat Enterprise Linux, which includes supported Tomcat stack, as well as MySQL. So you don't have to worry about that. Also, what you get is you can also specify your template repositories. Like if you have a big organization where you want to start your application, Magnolia application, with a specific template repository, you can specify that, and we will use that to create the application. So all the developers in your organization can use the same template repository. That brings a lot of standardization in your organization. Now, the second point is that OpenShift supports automated deployment. So you don't have to worry about that. I have to build my WAR file, then I have to take the WAR file, take it to a test environment, then I have to deploy it. OpenShift can automate all of these things yourself. OpenShift by default uses Git, which is a distributed version control system. So when you create an OpenShift application, it also contains a private Git repository, and you just use Git for deployment. You can just say git add, git commit, and git push. On git push, we will build the project and deploy the application for you. So it automates the deployment. Because you're not managing the application stack, and because you're not managing the IaaS or the infrastructure underneath that, you get you drive business agility and you reduce time to market. So you can just focus on your application code and you can take your application develop faster. Fourth point that we have is OpenShift being a auto-scalable platform as a service. So you can, at application creation, you can say that I want my production environment should be auto-scalable. So what we will do is that we will create a scalable application which will have HA proxy as a load balancer and multiple Tomcat instances which sits behind that. So depending upon the number of concurrent requests, we can spin up Tomcat instances or JBoss instances as required. So as a organization, as a developer, you don't have to worry about that. The platform takes care of that. So this could be very helpful in case of your Magnolia installations. The use case where we can use Magnolia and OpenShift together is if you want to spin up, in case of a disaster, you want to spin up instances on public cloud. You also have in your private infrastructure, but in case of any demand or in case of any disaster, you want to spin up instances faster. So you can use OpenShift for that as well, because you can automate all those things, and you can specify your application creation. So you can use that to create your application at any point that you want to. It makes your life much easier. So now I will hand over to Daniel, who will talk a bit about Magnolia and the different configurations of Magnolias that are there.
Yeah, thanks a lot, Jacob. So if you check out the configuration options for deployments in Magnolia, there's a bunch of minimal setups. There's more options, but I will just walk through a few of them. So first, you could actually have your author instance, that's the symbol with the red sign, actually running on a desktop machine if you just have one server at hand, but your public instance you might very well want to host on a server, so it's accessible 24 hours a day and from everybody. Here I'm talking about a physical server, but now the cool thing is, as OpenShift is a standardized platform, actually this could as well be hosted by OpenShift. So for the next scenario, we can have two instances on one server. It's nice now, the author instance would be accessible for other people as well in 24 hours. You don't have to run your desktop, but yeah, you most likely would like to separate author and public instance for security reasons. Again, the scenario can be created with OpenShift as well. So yeah, separation means that you most likely will run the instances on isolated servers, physical or cloud platform. And the last minimal configuration I want quickly to explain is coming here, yeah. So that would be, you still have just two servers at hand, and now you have to check what to do with your three instances you want to run. You want to have one author and two public for failover. So you could either place the author together with one public, or have the author isolated and two public instances running. Both feasible, both probably not ideal if you want to go with a huge web page for production. So then we have another slide. I quickly wanted to explain how it will most likely look like in production. So the most frequent scenario probably is that you just have your author instance on a dedicated server and then n instances of public web apps. So you have nice failover. If one of the public dies, no problem. If you expect heavy load, well, you could probably just very easily spin up some more public instances. And if you have a short look on the full-blown scenario, this is actually a setup that quite a bunch of customers run, is that you want to have your author instance and your intranet having behind a firewall, so it's safe. And only the public instances are on the other side of the firewall, accessible from the outside, so that you can have this load balancing between the public instances. There will be a load balancer in front. And here, for traffic peaks, you might want to have some instances on hot standby. Maybe those are hosted in the cloud. So to summarize, there's a whole set of deployment options. All of these options can actually be applied to the hosting on from Magnolia in OpenShift. Thanks, Jacob.
Yeah, so now what we will do is that we will look at a couple of demonstrations. So we will start with a demonstration of OpenShift. I will just talk you through how you can get started with OpenShift. Once we are done with that, then we will look at a second demonstration where we will take a minimal configuration of Magnolia and deploy it on OpenShift. So the configuration that we are going to test is a separate public and a separate author instance. They both are running on different Tomcat instances and how they can talk with each other. So this is the configuration that we will demonstrate today. So before we start, we need to be comfortable with how we can get started with OpenShift. What are the toolings that we support? So we support a wide range of tooling actually. So we have tooling with Eclipse. The Java developer live and die their day in Eclipse. So we have a tooling Eclipse integration for that. We also have integration with IntelliJ IDEA. So if you are an IntelliJ IDEA guy or girl, you can use that as well. Apart from that, we also have integration with mobile IDEs. This is cool with mobile with IDE developers. We also provide tooling within a web browser. So if you just go to OpenShift.com, you can log into OpenShift console. The cool thing about this is that you don't have to install anything on your local machine. From the web browser, you can create applications. But when you have to write code, you have to use command line tool to create application on your local machine. The third tooling option that we have is a command line tooling, so which is a Ruby gem. So you just have to install a gem install RHC. So gem is a way to install Ruby gems. So once you are installed with that, it gives you a few commands that you can use to build applications. Personally, I like RHC the best, the command line tooling the best, because it has all the features that are required. Some of the features are not yet available in web browser and Eclipse IDE. Last but not least, we also expose our REST APIs to the people. They are well documented, and people can use them to build their own clients as well. So if you want to write your own client, you can just take our REST APIs, write and wrapper around that, and use that. So it depends on you. But we try to cover most of the people, but if people want to build their own APIs, or if people want to build their own clients, they can use that as well. So how you can get started with OpenShift? It's very easy to get started with OpenShift. You just have to go to OpenShift.com, sign up for a new account. You will get an email. You have to verify that email. Once done, you can get started with application creation. So let's just take a look at that. So I'm going to so OpenShift.com is the website. You have to create a new account, so you just click on sign up for free to create a free account. So when you sign up for an OpenShift account, it is a free account that you are signing up for. So free accounts give you gives you access to 3 application instances, so you can create 3 applications at the max. And every instance is 112 MB of RAM. Now, once you have created your accounts, application, so you just click on My Apps after that. It will show you an applications page where you will see a listing of applications if you have already created some applications. So these all are my applications. For you, it will be empty. Now let's create a new application. So what I will do is I will just click on Add Application to create a new application. Once you create an Add Application, it will show you a web page where you can see different application types. So as you can look here, so we support Java, PHP, Ruby, Python, and Perl, and Node.js language types or application runtimes. As this talk is mainly focused around Java, so we will just browse by Java. And this will open a page which will show you different Java application types that we support. So you can look at that we support JBoss application server, JBoss enterprise application server, Tomcat 6, Tomcat 7, a whole range of application server and web servers that we support. Apart from that, we also have integration layers. We also have BPM cartridge things. We also have a cartridge for Wildfly, which is the new version of JBoss, which is JBoss 8. So JBoss has been renamed to Wildfly, and Wildfly target right now Java EE 7. So if you want to see if you can run Magnolia CMS on Java EE 7 container, you can go to Wildfly. You can create a Wildfly application and try that. What we will do now is we will create a simple Tomcat application just to talk about the developer workflow. You go and you click on that. It will show you a web page where you need to enter some details. So the detail include what is my application name. So let's say my application name is my app. It could be anything. It could be any alphanumeric characters. After entering your name, you have to specify a domain name or a namespace. So this allows you to have different environments. So as you can see, I have 3 domains. So I have a domain called T20, Dev T20, and SG Demo. So all of these corresponds to different environments that I have. So T20 is where I run my production applications. Dev T20 is where I run my development environments. SG Demo is what I use for conferences. So let's take SG Demo. Sign up for a free account. You only get access to creation of 1 domain name. So you can't create more than 1 domain in the free account. You have to upgrade to our paid tier for that. But you can create 1 domain name, and it is required for application creation. So every account needs to have at least 1 domain name. Once we are done with that, you have to specify a Git repository. This is required in case you already have written the source code of your app. So you can specify a Git repository and give it a branch and a tag. But we are creating a new application, so we will not enter any details here. Next, what you need to do is that you need to specify the configuration. By configuration, it means how much RAM we should give to you. So by default, you will only have access to small gears, which are 512 MB of RAM. But you can also get access to medium, which is 1 GB of RAM, and large, which is 2 GB of RAM. These are available in paid tiers. I will use large gears in this demonstration. Then you specify that I'm using Tomcat 7 cartridge. Then last but not least, you can specify whether you want to create a scalable application or a non-scalable application. By scalable, it means that we will have multiple Tomcat instances. By non-scalable means we just have one instance where we will install Tomcat and databases if required. For this demonstration, we will just go with single instance, that is no scaling. Then we will press create application button. So when we press create application button, what we do is that we make a RESTful call to our OpenShift broker, which is a Rails application, which takes this request data and create a new instance of that application using all this data. So what it will do behind the scene is that it will create an instance, install Tomcat on it, install Java on it, and create a demo application for you. We already have created that demo application or the dummy application that we required. We can just go and look at the application page. So this is what you will see for an application. So every application has a public domain name. So if I just click on that, so you can see that this is my application. So this is a hello world kind of an application that OpenShift creates for you. Apart from that, you can also add databases. So you can add MySQL, PostgreSQL, MongoDB, whatever database that you need to add for your application. Also, you can say that I want to use Jenkins, which is a continuous integration server. You can do that. So with Web Console, you can do all those stuff. But the point is you want to write code. So to write code, you have to get the source code or the template application that we created on your local machine. To get the template application on our local machine, there are multiple ways to do that. The first is you can just take this is that Git repository that we created. So you can just copy this location, go to your command line. This is the command lines. And you can just do git clone here. So you can just say git clone application. That's one way to do it. But we also support, as I talked before, we also support integration with Eclipse, which is an IDE. So what you can also do is that you can go to Eclipse, go to Eclipse Marketplace, install JBoss Tools plugin. JBoss Tools plugin integrates with OpenShift applications. Once you are done with that, you can start importing OpenShift applications. So what I'm doing right now is that I just right click on my package explorer and just importing an OpenShift application that I created. So now I'm just saying import my existing OpenShift application. Then I will be asked to verify my credentials detail. I will just press next. Then you will see a screen where you can specify which application you want to import. So you can see that this is the application that I want to import. So I will just refresh the details in case anything has changed. So this is the application that we have. So I will just take it. So once I've selected that application, all my details are filled. So this is the name of the application. It is using Tomcat 7. It is using large gear, which is 2 GB of RAM. Then I can press next. So it will ask you whether you want to create a new project. That's fine. Just press next. Then it will ask you the location where you want to clone your application. So this is the default location that it is using right now, but it can be anything that you want to set up. Then you just press finish after that. So now what we will do is that we will import this application, we will clone this application on the local machine and then import it as a Maven project. So in few seconds, you will see that my app is imported as a Maven project. So now this is a standard Maven project. It does not have anything specific to OpenShift. So if I open pom.xml for Maven projects, you will see that it just contains a couple of dependencies. So the dependencies contains are for PostgreSQL and MySQL Java drivers. Apart from that, it is just a standard Maven POM file. Only thing specific to OpenShift is a Maven profile called OpenShift. So when you push source code to OpenShift, when you deploy it, OpenShift uses this profile to build your project. This will get clear once we make a change and deploy that. Apart from that, what it contains is just a few HTML file and JSP files. So let's open index.html that we were seeing in the page. This is a standard HTML file, nothing fancy here. What we will do is we will make a small change right now. So we will say that welcome to OpenShift and Magnolia CMS to just walk you through the development workflow. So now what we have done is that we have made our first change to our application. OpenShift creates a server for your application in the servers panel. And you can, now that you have made a change, you can just right click on that and just click publish here. So it will show you that I am using this message, so I can say that made a change. So this is a simple get message that we do, made a change, and press yes. Once we do that, OpenShift will push all the bits to the Git repository that it created. So now you will see that in few seconds it is publishing. So it first stopped Tomcat instances, and then it is just building a Maven IDE. This is just a Maven clean install that it is trying to do. And now it will download all the jar files on the loop that are required to a project. So this is one way to work with OpenShift. What you can also do is you can, if I go back to that repository, so this is the location where we created our project. What you can also do is you can just use standard Git tooling. So you can also say git add, git commit, and git push. So you can also do this as well. So there are multiple ways that you can work with OpenShift. If you use Eclipse IDE for most of your work, then you can use Eclipse. Otherwise, you can also use Git tooling as well. So now you can see that we have deployed our application change. So within seconds, we have our application change deployed. And from within Eclipse, we can just say show in web browser to look at our application. And now you can see our change has been deployed. So within few minutes, within few, I think, seconds, you have your application created and you made a change and deployed it. I just showed it a very simple use case, but this could be any Maven project that you have. So now you have looked at that how you can create application using browser as well as import that in an Eclipse IDE. Let's move ahead with the main demonstration that we have for today. So what we will do now is now that you know how OpenShift development works, now what we will do is that we will create a couple of OpenShift applications. One for our author instance, one for our public instance. We will make configuration changes that are required so that they both can talk with each other. And then we will have our author and public instance running. Now, if you're wondering, like, does OpenShift only support source code deployment? Like what we did here is source code deployment. So we have our Maven project and push that to OpenShift. But OpenShift support multiple deployment platform ways. So if I just do ls here, you will see that there's a directory called web apps also here. So this is a standard Maven project, pom.xml and source. So if you want to do source code deployment, you can just make changes to them. But let's suppose you don't want to do source code deployment. You want to just publish your war file. So what you can do is you can just remove source and pom.xml. So you can just delete it. And what you can do is you can copy your war file. Let's say our war file is root.war, and copy that to web apps directory. Once you have copied the war file to web apps directory, you can directly publish your war file as well. So OpenShift supports multiple ways of deployment. Some people are not comfortable with pushing their source code on it, so they just want to publish the war file. So that's also supported with OpenShift. So let's go to our main demonstration. We can create a couple of instances of Magnolia instances. So let me just go to my command line. So what I will do now is I will create a new Tomcat application using a template Git repository. So what I'm doing here is that, again, we have looked at tooling, we have looked at browser. So now this is the third way to work with OpenShift. So this is a RHC gem that I talked about initially. So what we are doing here is that we are saying that I want to create an application, RHC app create. This is a standard command. I want to create an application whose name is mgauthor. Mgauthor is the name of the application, just like we have name called my app. Then what I'm specifying is that I'm saying that Tomcat, please use Tomcat 7 cartridge for that. And this is the namespace that I want to use, sgdemo. And I want to create a large here, so which means 2 GB of RAM. And please take this Git repository as my template application. So when I was talking about the standard application environment that you can say. So you can just use -- from code and specify a template repository that OpenShift will use to spin up the application. Now we will just press this command. So it again, this what it is doing behind the scene is it is making a REST call to OpenShift servers, taking all the configuration that we provided here, creating a Tomcat 7 instance, taking a Git repository that we provided here, which is here, and creating an application based on that. So this is available on my GitHub account. So this is a simple template, the application that we are creating. So if I go back to my GitHub account, so this is the application that I have. So it's available open source, anybody can grab it. I also have specified the command that you guys can use if you don't remember it. So in the last demonstration, I specified how you can change source and pom.xml file, but you can also do war deployment. So here we are not having source and pom.xml files, so I have deleted those. Apart from that, what I have is a web apps directory. So web apps directory is where if you want to do war deployment. So if you go in that, you will find that it is empty right now. The reason it is empty right now is because the file is 135 MB and I don't want to download all those things myself. So what I'm doing is I have written a script which will download the war file and put that war file in the repository location that OpenShift requires. So every OpenShift application has a folder called .OpenShift. This is for configuration stuff. So like what you can do is that you can specify different action hooks for different lifecycle events of the application. So if I see here, we have one action hook specified here, which is pre-built JBoss EWS 2.0, which is pre-built Tomcat 7. So before application is built, what it is trying to do here is it is downloading the latest version of Magnolia war file. So it is just wgetting it and then renaming it to root.war and then copying that war file to a repository directory. That's what it is doing. So it is nothing fancy here. We are just writing a script which downloads a war file. So similarly, you can get different action hooks. Like you can get action hooks after deployment, before deployment, and stopping and starting. Action hooks is just one folder. We have different folders like configuration. So config is specifying your Tomcat configuration file. So this is your standard context.xml and server.xml. So if you want to make some configuration changes to Tomcat cartridges, you can override these files as well, and OpenShift will apply those changes. Similarly, we have a cron where you can, what you can do here is you can specify cron commands like cron jobs, like you want to clean the log directory daily. So you can write a cron job here. You can just write a daily script. The last thing that we have is called a markers directory. So markers provide some configuration options like the one that we have right now. So we have a configuration, a file called Java 7. It's an empty file. There's nothing in here. But what it tells OpenShift is that it tells OpenShift that I want to use Java 7. Let's suppose you don't want to use Java 7, you want to use Java 6. So what you will do is that you will just delete this Java 7 file and OpenShift will fall back to Java 6. Now, if we go back to our application, so you will see that our application is created. And if we just go to mgauthor here, open that in our web browser, it will open the which will install few tasks. Daniel can just walk through which all tasks it will install. Daniel, can you just talk about that?
Sure. So what we see now, that's exactly the same as if you would install a fresh Magnolia on a local machine or on a server. Magnolia is starting up, repository is empty, so all the modules will take care that the required content is placed in the appropriate workspaces, JCR workspaces, and well, installation order, as you know, in order of dependency of the modules. And now you see that it just take a short moment, messages and everything as you would expect it. So you know it from the from other installations on other platforms. Here we're seeing the author, and of course, same thing has to happen for the
so we also have, so to save time for this demonstration, I already have created the public instance. So public instance is already running. It's again the same instance. So it's again the same author instance that we have, and we have to configure that to make a public instance. So yeah. Yeah, so it is currently installing all the tasks that is required. So once done with that, we can log into the admin central. So the public instance is just the same. So what I have is the second command. Again, the command is just the same. So if you look at the directory, so we are using the same Git repository that we have. So we are taking the same war file, Magnolia standard author war file. It's not different from anything, but we are just naming it to MG public. Now, Magnolia documentation provides a step-by-step way to convert a author into a public instance that we will do next. So if you just go back here, we are almost done with our task. So now our Magnolia instance, author instance is getting ready. So it's almost done now. Yeah, so now we just press start up Magnolia. It will start up the author instance. First time it takes a bit of time. Yeah. So Daniel, can you just walk us through the steps that we require to convert an author instance to a public instance, and I will just follow that.
Yeah, sure. So we just do the minimal steps. This is on the one side, make sure that the server/admin setting in the configuration workspace set to false.
Yeah, so I'm just doing that. So we have to change our admin to false. So that's the first configuration change that we have to make. The second change that we have to make.
Yeah, and the second thing is, well, the difference on the public instances that you want people that are not authenticated still be able to access your website. So we have to enable the anonymous role with certain rights. And this is, of course, not something you would want to have on an author instance.
Yeah, so we are just changing our anonymous user, and we will just provide few rights in here. So we will just make a read-only access, and we will make get and post request in here. So now we have converted this author instance into a public instance. So if I just go back and open a new project, so now I will not be asked to log in because that's a public instance now, and we will see a Magnolia public instance running. So this is a standard demo project that you will see in every Magnolia project. So as you can see, there are 6 pages right now. So what we will do is we will publish a new page from author, and you will see that page listed here. Yes, so now our author instance is also ready. So we'll just log in. Yeah, Daniel, can you just walk us through steps that are required now for author and public to talk with each other?
Yeah, yeah, sure. So now we have the scenario where we have 2 instances running, author and public. They don't know from each other. Despite the fact that this is in the cloud, it's just the same procedure as you know. So we have to make sure that the subscriber on the author instance points to the URL of the public. So
yeah, that's what I'm doing. So,
yeah.
So yeah, so I'm just doing that. So by default it uses localhost, but we don't have to use localhost. So we will just copy that public location and we will update that here. Yeah, the first change is done. The second change, Daniel?
Yeah, and now the final thing is just we now already have the location, but to establish a handshake so that the author actually trusts that public instance, we have to make sure that the public key of the author instance is used on the public instance as well. So you can just simply
so I just copied the public key of the author, and now I will go to the configuration of public instance and we'll change that in here. So in the activation public key, I will just update that. So this will make sure, this will make sure that both author and public instance can talk with each other. Once we are done with that, what I will do now is to finish this demonstration is we will create a new page now. So on the author, and that should get published on the public instance. Now we will just do an add page. We will create a new test page, and we will use a template. Let's use news overview template and save changes. Now what we will do is that we will just publish this change. It should work, yeah. So now we got a publication successful, which means that our page has been published. So now if we go back to our public instance and refresh the page, it should have a test page. So it was all the standard procedure that you have to follow to create an application on OpenShift. There is nothing special here. So we are this is a standard time test page that we published. And you can see that within 10-15 minutes, we have our author and public instance running. So that was just a simple demonstration of a distributed application, but you can take this to standard deployment configurations as well. Yeah, one thing that you should be aware of when you're trying to use OpenShift with Magnolia is that by default, the directory where it will write your data is non-persistent. Fine. So you have to specify a directory location called app root data to write your data. So in your magnolia.properties file, you have to make this change. After this webinar is done, I will document all these steps and make sure that I mention these things there. So now we have done with that. So what we will do is we will just talk about few slides where we'll talk about what OpenShift did underneath, what are technologies that OpenShift is using, just a few couple of slides just to make sure that you understand the underpinnings. So let's talk about what OpenShift, how OpenShift works. So OpenShift is a platform as a service that we already have talked about. It is it manages your, it runs on your top of your infrastructure. So infrastructure could be anything that runs RHEL. So OpenShift runs on top of RHEL, Red Hat Enterprise Linux. We can run on top of bare metal, which means you have a desktop server running Red Hat Enterprise Linux. We can run on top. So if you have Red Hat Enterprise virtual images, we can run on top of that. We can run on top of public cloud like Amazon EC2, or we can run on top of private cloud like OpenStack. What we need is Red Hat Enterprise Linux. That's the core of OpenShift. You can also run OpenShift on Fedora and CentOS, but those are not supported versions right now. So the standard supported version right now is Red Hat Enterprise Linux. So if your organization uses that, if you are using Red Hat Enterprise Linux, it means that you can run OpenShift Enterprise in your organization. So OpenShift in itself is composed of two components. One is called a node, another is called a broker. So node is where your application runs. So when you created an application, what we did behind the scene was that we created a small instance inside this big node. So what we do is that we take a big instance of RHEL and chop that out into smaller instances using Linux technologies like SC Linux and C groups. The second type of servers that OpenShift has are called brokers. So brokers are the front facing. So they expose the REST API, which your different clients talk to. So your client, be it a command line client, be it Eclipse, or be it web browser. So they talk with the broker. Nobody talks directly with the nodes. Nodes are where your application are hosted. So when you make a request to create an application, that request is intercepted by a broker, that is received by a broker. Broker sends a message on the queue to check which node can fulfill the requirements. And one of the nodes will satisfy those requirements, and that node will host your application. Node is divided into smaller parts, which are small. So every application has at least one gear. These gears are based off standard Linux technologies like SC Linux, which allows you to have security constraints so that multiple gears can't talk with each other. And they use another Linux technology called C groups to manage your resources, like how much RAM and how much CPU that they have. Once you're done with that, you get a isolated process, where isolated container where you can run your applications, a secure way to run your applications. Because we are not using virtual machines, we are using containers, so it's very lightweight and you get better hardware utilization. So that is the underpinnings of OpenShift. So we have just covered small internals of OpenShift, what it is using. So now we are almost done with the session, so we are ready for questions, so we can answer that.
All right, well, so far we have 3 questions. Okay, so the first one, and they seem to be more general about OpenShift. The first one is, I think, fairly simple. Is it possible to use OpenShift in Windows? And I'm going to add a little bit of specificity to this. As a developer working from Windows, I think that's one question. I think you've already very clearly answered that the OpenShift platform itself requires Linux. But for a developer working from Windows, would they face any challenges?
Yeah, you can work. No. You don't face any challenge. So you have multiple ways. So like Eclipse can run on any of the operating systems. So you can run on Windows quite easily. You can use RubyGem, which can also run on Windows. So working with OpenShift from Windows is standard. So most of the developers use that. So you can do that.
Great. The next question is there any way to synchronize MySQL database repositories back to my local machine? And this is just manual synchronization, but I imagine
So you're
that.
talking data export kind of a thing.
Yeah.
Yes, what you can do is that you can connect with the, suppose you create a Magnolia application and you said that I want to use MySQL database to manage my data. So what you can do with OpenShift is that you can connect with that MySQL database and you can take a database dumps of that data and you can just make your instances synchronizable, but that you have to do manually.
Okay. The next question is, how can I change Apache HTTPD or NGIX settings?
No, you can't change that.
Okay.
So what we do is that because you are using Tomcat here, so we provide you configuration for Tomcat that you can change. So if I go back to my location where I created an application, so this was my MG public. So let me just open that in an IDE or text editor, and I will just open that. So if you want to update configuration of Tomcat, there is a directory called .OpenShift, which has all the configuration options because you will be working with Tomcat here. So you can change those configuration. If you are creating a PHP application where you need to do that, then you can change HTTP configuration of Apache. But with Java, will normally have to change configuration of Apache Tomcat that you can use. Okay. So this is a standard Tomcat configuration that you can update.
Okay. How difficult would it be to set up a clustered repository on such an OpenShift setup of Magnolia?
I think Daniel has to help me out with that.
I think so.
I give my best. Yeah, I give my best. So yeah, as Shekar pointed out, you can have a MySQL installed in OpenShift. That's not a problem. In such a scenario, you would have your, well, it would be the same setting up that cluster as if it was on a server. Just had your two public instances probably running on a separated gear each, sharing that one MySQL database. So actually, I never tried that out, but it should be very similar to what you would have to do on a physical server.
I think one configuration that can be easily done is suppose you can have multiple public configuration or public instance running. So like we added one public instance configuration, you can also add multiple public instance configurations. This should work standardly. So that, because right now I'm using community edition of Magnolia, which does not allow you to have multiple subscribers, but with production environment, with enterprise version of Magnolia, you can have multiple subscribers. So you can add multiple public instances. That should be fairly standard.
Yeah, and I think that the question is aiming on whether this setup where you have actually two public instances running using the same MySQL database and just publish to the one, that should work as well. Yeah, I don't see the reason why not.
Any other question?
Is it possible to have HTTPS access?
Yes, you can do that. So, but that is not available in the free tier. But in the paid tier, you can upload your SSL certificates and do that. That is a feature of paid tier. Yeah, you can also have your own domain names. Domain names can be done in free tier as well. But SSL and HTTPS is a paid tier feature. You can do that.
Okay. Is it possible to run Magnolia, an instance of Magnolia, on a small gear?
Yes, I do that. So you can do that. So what we do is that we provide you 500 LB of RAM and 1 GB of disk space. So you can do that. So you can try that out and it works. So I have tried that. The reason I use large instances is because I'm working out of India. I don't want a lag in it. So I want to use the faster instance to demonstrate. That was the only reason that I used a large instance.
Okay. The question queue is now empty. Are there any other questions that people have? I think silence seems like a good answer. So that'll conclude today's webinar. I think we've done an excellent job of being on time. Thank you very much, Shekar, and thank you, Daniel. I really appreciate the time that you spent, especially in rehearsals, and the information and experience you shared with us. Thanks to all of our participants. We're very glad you could join us today and hope this session was useful for you. If you look in the chat window, you can see that I've posted contact information for both Shekhar and Daniel. We'll send out an email to you later on that has links to the assets from the webinar. In the meantime, happy hacking, and we will see you again at our next webinar. Enjoy the rest of your day.
Yeah. Thanks. Bye.
Thank you.